All right. Welcome. My name is Zachary Shalson, and today I will be presenting all about color mixing. So in order to get started on color mixing, the first thing we have to do is understand what is light and what is color. So what is light? Most basic question of optics. Light is made up of energy waves that are grouped together. So light travels as part of the electromagnetic spectrum, and it travels in waves. Our eyes can see what's called the visible spectrum, which is where we get our colors and our wavelength ranges. So each beam has an associated wavelength and thus an associated part of the electromagnetic spectrum. For example, the shorter wavelength we get as part of the visible spectrum, we will get blue light, versus when we have a longer wavelength, we'll get more red light. However, if you wanted to get a super short wavelength, those are your UV, your X-rays, and your gamma rays, versus your super long wavelengths, which are your infrared, your microwaves, and your radio waves. So as I was mentioning before, this is the electromagnetic spectrum. As you see here, we do have the longer waves, the radio waves, microwaves, and infrared. And over here we have the ultraviolet, X-ray, and gamma rays as part of the shorter wavelengths. And right between infrared and ultraviolet, we have our visible light spectrum, which is where we get all of our colors, going from red all the way to violet. So now to talk more about the colors, we're first going to talk about the subtractive color wheel. This is kind of your classic color wheel you learned from elementary school, where your primary colors are your red, your yellow, and your blue. Now from these first primary colors, you can then make your secondary colors, which are your orange, your green, and your purple. From there you can go to your tertiary colors, your citron, your russet, and your buff, which is, a yellowish gray, reddish gray, and bluish gray. And then from there you can even go further to your quaternary colors, which is your plum, your olive, and your sage. So your orangish gray, your greenish gray, and your purplish gray. So as you get further down the line, you get more and more gray, kind of getting more and more darker colors. So subtractive color mixing is used when mixing pigments or mixing inks. As you might see on a printer, you might see your CMY colors. Those are your cyan, magenta, and yellow colors, producing all your colors that you would see on paper. So as we have in this diagram, we have some light coming down to this purple paper right here. However, as you see, it's absorbing all this green light, and it is reflecting both the blue and the red, which is what our eyes will see. So from the subtractive color mixing, we will see the colors that are only reflected and not the colors that are absorbed. So as you see in the image, it starts out as white light, and then it comes down and becomes more dark as you mix more and more colors together in the pigments. So that's why it's subtractive, because you're starting out as bright white light going all the way down to dark and black. With subtractive color mixing, we have to talk about the opposite, which is additive color mixing. So as I said before, subtractive is used when talking about mixing. It reflects the light that makes the color, and it begins as white light becoming more and more dark. However, on the flip side of that, we have additive color mixing, which is used when mixing light. So we're moving away from pigments, and we're using light, so like your flashlights and things like that. So additive light actually begins as dark, and then becomes more and more white as more colors are added. And I'll do a little demonstration of that in just a few minutes. But a little background on additive color mixing. We have a little bit of history to go over as well. So systems of additive color are motivated by the Young-Helmholtz theory of trichromatic color vision, which is what you see in this diagram right here of the eye. We have all these cones which pick up your red, green, and blue receptors at the back part of your eye. Those are your color rods. Now, James Clerk Maxwell, who is considered to be the father of additive color, actually helped prove this theory that we have red, green, and blue receptors in our eyes with his ribbon experiment. Now, this experiment took a single picture of a ribbon, and what he did was he captured this image in 3 filters. He captured it once with a red filter, as you see all the way up top left here. We have the image of the ribbon with the red filter. Next to it, we have the image of the ribbon with the green filter. And over here, we have the image of the ribbon with the blue filter. Now, when you combine all those images and overlay them on top of each other, you'll get this pristine image of the ribbon as you see right here, perfectly colored in all the colors. We can do another example too. We have this beautiful looking house right here. And what we've done is we've taken it in each of these different filters. So we have the red filter on the far left here, the green filter, and the blue filter. Looking at each one individually, you don't really see the whole image, but it's only once you combine all three filters on top of each other, or once you combine all those three images with those filters, you really get to see the entire full image. So we now are going to change from our subtractive color wheel, which consisted of red, yellow, and blue, to our additive color wheel, which consists of red, green, and blue. This is where you might hear your RGB. From these, if you combine red and green, you're actually going to be getting yellow, which is a little interesting to think about. If you combine red and blue, you're going to get magenta. And if you combine blue and green, you're going to get cyan. And if you combine all those colors together, you're actually going to get pure white light. And we can actually do a little bit of a demonstration of this as well. So we're going to switch to the overhead camera. Perfect. All right, so right here I have a little box or a little table right here, and I can hover my hand over these different sensors to produce different colors light. So right now I'm hovering my hand over the red sensor, and as you see in the video, we are having a red strip of LEDs right here. If I hover my hand over the middle sensor, we get the strip of blue LEDs. And if I hover my hand over this left sensor, we get green LEDs. And we can go ahead and prove this entire color wheel that we just talked about. So for the additive color wheel, if we mix red and green, we're actually going to see yellow light. So right now, this is a combination of the red and green lights, and it looks pretty yellow to me. Next, we can go ahead and add red and the blue light, and this is going to give us our magenta color. We can then add the green and the blue light to give us our cyan color right here. And if we wanted to combine all three colors, we're going to get pure white light as you see here. Now this is also really fun because you can also just hover your hand over this and kind of go back and forth between the colors and make more colors kind of all over the place to get your entire rainbow visible spectrum that we have as part of the EM spectrum. All right, so places that you would see this are in computer monitors and TVs. You might hear LEDs before. LEDs are made up of the red, green, and blue diodes, which is super interesting because every color that you see on your computer screen right now is actually being made of those red, green, and blue lights. In different ways, the computer makes it so it's super fast and you can't really see them because those LEDs are very, very tiny. In fact, you could take a small little magnifying glass and hold it up to your computer, and you might even be able to see those LEDs. So I challenge you to actually go online, search up picture of yellow, just pure yellow, and if you hold up a magnifying glass to this screen of yellow, then you're actually going to be able to see only the red and green LEDs lit up. You won't see any blue. And this is just to kind of help prove to you that these colors are additive and making up the color yellow by just using red and green. With that, that will conclude the end of this color mixing presentation.